Okay, mathematicians did this over 2,000 years ago in Babylonia. They derived the quadratic formula, which is a method to solve quadratic equations. So, I mean, you can solve these equations by factoring, completing the square, and a couple other ones. And then what they did, this is what they did. They're like, okay, ax squared plus bx plus c equals 0. So you have a plus b plus c equals 0, but we have these factors, these variables, x, not factors, these variables. A variable squared, a variable squared plus b variable plus c equals 0. So you have these two variables and this square, we got to figure it out. So we do the quadratic formula. Well, we have to derive it first, though, these mathematicians. This gets a little tricky, but it can be done. Okay, so you have your problem here. So you want to divide a, eliminate a out of it. So ax squared plus bx plus c equals 0. Eliminate the a. So you put a underneath it, underneath a under there, underneath the a crosses out, so you're left with x squared plus b over a x plus c over a equals 0. Alright, good so far. Now, we have this formula right here, and you got to complete the square now. This is where it gets really fun. So, to complete the square, remember the rules. Divide by 2, and then take it to the second exponent. So, square. So here's your second term. You do this to the second term, b over a. So you have b over a divided by 2. Saying b over a divided by 2 is like saying b over a divided by 2 over 1. So you have b over a divided by 2 over 1. When you're dividing something, you flip it when you multiply it. So b over a times 1 over 2 equals, you just multiply across, b times 1 is b, and a times 2 is 2a. You have b over 2a. Good so far. b over 2a. Your second rule is to add an exponent, square it. So b over 2a squared, which is b squared. The square is 2 times 2 is 4. 2 times a is a to the second. So b over 2 over 4a squared. Good so far, right? You divide it by 2 and then you take the square of it. So that term right there, so then your original is x squared plus bax, you keep the same 2 in there. Then you add what you got over there here, so x squared plus, let me get this x in here, alright, because it's kind of get a little OCD here. So x squared plus b over ax plus that term you found, b squared over 4a squared, equal to that same thing you add to both sides. So b squared over 4a squared, and then here we throw the c over a to the other side, so minus c over a. You're going to do that eventually because you're trying to solve it. So now this is when it gets really fun. You have this side of the equation you're trying to solve and this side of the equation you're trying to solve. So this side over here, you do your math wizardry because you're experts at completing the squares, and you're just wizards. You come up with x plus b over 2a all to the second power. You're wizards. Now this side, this is what you do. Alright? You have yourself b squared over 4a squared minus c over a. It's like adding fractions. Just think, 1/3 minus 2/3, where you put one over the other. Just do the same thing. These are letters, but just do the same thing. This is a breakthrough. Watch. You have all that junk. So you put c over, it's minus ca. You have negative ca up here. And then, this is what's beautiful over it. You have b squared over 4a squared. That's all you gotta do. You're adding your fractions or whatever, subtracting kinda. You just put those two there. So your like term, you have your a denominator and you have 4a squared. Your common denominator is 4a squared. A goes up to 4. This is like saying 1a. 1 and 4, your common denominator is 4. There's your 4a squared. A and goes up to a is a squared. So 4a squared. Alright, you write that. So this, what times that equals that is 1. So 1